Hello everyone, welcome you all for this session. So in this session, we are going to see one example of Thevenin's theorem. So let us see the example statement in the circuit. So see the statement. So find the circuit current flowing through the 10 ohm resistor by using the Thevenin's theorem. So let us see the circuit here. So we have the two sources. This is the complex circuit. And we have to reduce this complex circuit and we have to find out the current flowing through this load resistance RL, IL through the RL 10 ohms by using the Thevenin's theorem. So as we already covered this Thevenin's theorem theoretical part in the video session, which is already posted in this channel. So please go through that video which is given in the description. So in that we have discussed the Thevenin's theorem procedure. So right now we will just follow that same procedure to solve this problem statement. So finding the current IL flowing through the 10 ohm resistor by applying a Thevenin's theorem. So what are the steps we have to follow to find out this circuit and to find out the current flowing through the 10 ohm resistor? So basically we discussed the 5 steps to solve the Thevenin's theorem. The first step is step 1. So you take it the step 1. Step 1. So what is the step 1? So the step 1 is remove the load resistance. Remove the load resistance. Which one is the load resistance? Our 10 ohm resistance is the load resistance. Remove the load resistance RL, that is a 10 ohm from the circuit. So this is the first step to solve your Thevenin's theorem. So in this, just we are finding the first step. So in this, just I am redrawing the circuit after removing load resistance RL. I just redraw the circuit again. Just see here, 4 ohm resistor and 3 ohm resistor, 2 ohm resistor, and again 2 ohm resistor, and source of 20 volts, 6 ohm resistor, and 6 ohm resistor, source of 25 volts. And this is our circuit of terminals A and B. So here this is the plus and minus 20 volts, and this is 2 ohms, 4 ohms, 3 ohms, 6 ohms, and this is 6 ohms, plus and minus 25 volts, 2 ohms. So what we have done in step 1. So see here in step 1 what we have removed the load resistance RL value. We have removed the load resistance RL value 10 ohms from the circuit. So this is the first step we have studied in while we are explaining the Thevenin's theorem. Now, so we'll go to the step 2. So what is the step 2? Step 2. Step 2. Finding the VTH, that is a Thevenin's equivalent voltage at terminals A and B. That means we have to find out the voltage VTH at the terminals A and B. Now, what steps will follow to find out the voltage at terminals A and B? So, whatever the method you follow, either you can follow a mesh analysis or nodal analysis, or whatever may be simple KVL KCL. So, here in this problem, I just want to apply mesh analysis here. Just I am applying a mesh analysis. First mesh current I1, and I am applying a second one current I2. Right. So now in this case, just we are I am interested to write the equations of the first mesh. So what is the equation? You can see here, this is the plus and minus, this is the current entering plus, and this is the minus, plus and minus. as the current is entering this side, plus and minus. Now you apply a mesh analysis KVL loop equations in the first loop or first mesh. So what you can get? So this is the voltage rise, or you can write it 20 volts. 20 volts is equals to. So what is the equation of current? 2 ohms. 2 ohms. The current flowing to the 2 ohms is the I1. The current flowing to the 2 ohms is the I1. Plus next resistor is the 4 ohms. And the current flowing to the resistor is also I1. And the plus next one is a 6 ohm resistor, and the current flowing to the resistor, assuming that I1 is greater than I2, because I1 is in this direction, so I1 minus I2. So this is your equation 1, first mesh loop equation. First mesh loop equation, you can see it. So your 20 voltage rise. So I just, because it is a source, and these are the power consumptions, voltage consumptions. So voltage source and voltage consumption. So voltage rise or voltage drops, which are both are equal in one mesh. If you apply a KVL equation, you can get a 20 volts is equals to 2 into I1 in the first resistor, 4 into I1 in the second resistor, and 6 into I1 minus I2 in the 6 ohm resistor. Now, the similar way, if I write the mesh analysis KVL loop equations in the second mesh, if I write it, so what I will get? So I will start from here, 6 into. So here we are assuming I2 is greater than I1, because in the second current direction is the opposite to the I1. I2 minus I1, 6 into I2 minus I1 plus 3 into I2. The current flowing to the resistor 3 is the I2 plus again the current flowing to the 6 ohm resistor is the I2, which value, and plus the voltage value is 25. This value is equals to 0. This is equation 2. So majorly most of them are confusing by writing a KVL equation, particularly the sign. So there is a one simple procedure to easy to write these equations. So when you are just if you are writing equation like this, so just you have started from here. If you have started from here, when you are moving from this here, you can see it is a plus and it is a minus, right? So it is a plus and it is a minus. You can write the 6 I1 plus I2 minus I1. So plus, because I2 is greater than I1, and this one is the plus and this one is the minus. So obviously this is the sign is same 3 I2, and this one is the plus entering and current leaving is the minus 6 into I2 plus and minus 25. So all the signs are same because it is 0. Here if you write it here, so this is the start with minus, so that's why I have written the 20 volts in the other side. The remaining all are in the same sign. So very easily you can apply KVL to find out this equation. Now, so thing is I have to find out what is the I1 value, and I have to find out what is the I2 value. So So there are two unknowns in your two equations. So we can easily find out by solving these two equations. So if you solve these two equations, what I will get? So from the first equation, I can write it the I1 coefficients and I2 coefficients. What are the I1 coefficients? So your I1 coefficient is a 12 I1 from the first equation, minus your I2 coefficients are 6 I2 is equals to, so what is the total coefficients? 20. And this is equation 1. Notice the second equation, if you see it, minus 6 I1, second equation if you solve it, minus 6 I1 plus 15 I2 is equals to minus 25. So this is the equation 1 and equation 2. Then if you solve the equation 1, you will get like this, and if you solve the equation 2, you will get like this. Now if you solve these two equations to find out the equations, how you can find out? So multiply the coefficient of 12, coefficient of I1 to second equation, and multiply the coefficient of minus 6 to first equation. So just what I'll multiply minus 6 to first equation. Here what I will get? 6 into 12, it is a minus 72 I1 plus 36 I2 is equals to minus 120. That is the first equation. Now the coefficient 12 is multiplied into the second equation. Again we will get a minus 72 I1 plus 180 I2 is equals to minus 300. So this is your equation after multiplying this one. I'm just changing the polarities of last equation, plus, minus, and plus, minus and plus. Let's changing the polarities of last equation, plus, minus 180 and plus 300. Now you can cancel each other and you can find out the I2 value. So your minus 144 I2, 144 I2 is equals to 180. So you will get like this, and finally you can find out your I2 is equals to minus 1.25 ampere, minus 1.25 ampere. In a similar way, if you substitute this I2 value and you can find out the I1 value is equals to, if you substitute this I2 value in your first equation, any one of the equations of these two, then you can find out the I1 value. You will get I1 value is a 1.041 ampere, right? So these two values you can find out. Now what is the I1 and what is the I2? So here you can see what is the I1. I1 value is a 1.041 ampere, and I2 value is the minus 1.25. So what is the meaning of minus 1.25? So earlier we assumed the direction in this direction, but when you are getting a negative sign, the current direction is the reverse direction. Just I am removing this direction, and your current direction is opposite to previous assumed direction. Current is in this direction, and your current is 1.25 amperes. 1.25 amperes, right? Now, after finding your current I1 and I2, now I have to find out the value of VTH. So how you can find out the VTH value? Just applying a KVL in the last loop, assuming this is the loop and this is the loop voltage of VTH, and just I am applying a KVL mesh loop equations here. Here you can assume the current here. Now, if I write the equation of this mesh, assuming this is the connected, this is VTH is the voltage which is there. Then if I write the equation of that, so what I can get? The first one you can assume, you can see it. What is the first expression? You can write it the 2 ohm resistor, and the current flowing to the 2 ohm resistor is 0. The current flowing to the 6 ohm resistor is the current I2, and of course there is a 20 volts. So I am writing the equation of this. So 2 ohm resistor and current flowing to the 2 ohm resistor is 0 plus 6 ohm resistor, and the current flowing to the 6 ohm resistor is 1.25 minus 25 volts voltage source plus VTH is equals to 0. This is the third loop mesh equations if you write it, right? So now my interest is to find out the VTH value. So what is the VTH value from this equation? If you find out the VTH value is equals to 17.5 volts. 17.5 volts, right? So this is the VTH value. Step number 2. We can find out the VTH value. Step number 2, 17.5. Now this is the second step we have find out. What is the second step? Finding the VTH value. This is the Thevenin's equivalent voltage at terminals A and B. So this is the voltage we have find out. This VTH value is equals to 17.5 volts. 17.5 volts by using a second step we have calculated, right? Now next one, third step. So what is the third step? Third step is you have to find out your RTH value. So we'll see the third step. So we are copying the same circuit to find out your third step. So we'll copy the same circuit and we'll just write a step number 3. Step 3. So what is the step 3? Step 3. So what is the step 3? Finding the RTH. That is a Thevenin equivalent resistance. Thevenin's equivalent resistance. So what is the Thevenin's equivalent resistance? So just we'll take the circuit which we have already taken in the previous. The same circuit we'll take it to find out the Thevenin's equivalent resistance. So here we'll see the same circuit and we'll find the Thevenin's equivalent resistance. So what we'll take it here. So here we'll just remove this content. So this is the circuit we have. This is the circuit we have earlier, right? So after before that. Now, while finding the RTH value, that means you have to find out the RTH value between terminals A and B. By seeing this side, you have to find out the RTH value. So how to find out the RTH value? While finding the RTH value, you have to replace your all sources with their equivalent internal resistance. Let's see here in our circuit we have two voltage sources. In our circuit we have two voltage sources. One is a 20 volts and another one is a 25 volts. So now whenever you finding the RTH value, you have to replace these two voltage sources with their internal resistance. So for a voltage source, the internal resistance is 0. For voltage source, the internal resistance is 0. And for current source, the internal resistance is infinite, right? So now I'm just drawing here 2 ohm resistor, and this is the voltage source. So here the voltage source is 0 means I have to short circuit. Voltage source is short circuit. And another voltage source is here. It is a 25 volts. It is a 25 volts. So just I am drawing again a 6 ohm resistor. 6 ohm resistor, and there is a voltage source. So this is also short circuited. Your two voltage sources short circuited and circuit having only resistance. Now it is very easy to find out what is the value of equivalent resistance RTH value. What is the equivalent resistance of RTH value? This will be the 4 ohm resistor. This is the 4 ohm resistor, right? Now, if you find out the RTH value, so first you have to solve these two. 2 plus 4 ohms. 2 plus 4, it is a 6 ohms. 6 ohms. And your 2 plus 4 ohms, 6 ohms is connected. So what I will call 2 plus your RTH value is equals to 2 plus 4. Your 2 plus 4, which is parallel with 6 ohm, and this combination is in series with this complete combination in series with the 3 ohm resistor, and this complete combination is parallel with 6 ohm resistor, and this complete combination is in series with the 2 ohm resistor, right? So if you solve this very easily, so 2 plus 4 is a 6, 6 is parallel with 6, your value is a 6 into 6 by 6 plus 6, that is a 3 ohms, and again 3 ohm resistor is connected in series, 3 plus 3 is 6, again 6 into 6, which is a parallel combination 3, and 3 plus 2, 5 ohms. So your RTH value very easily I can calculate a 5 ohms, right? So like this we can calculate the equivalent Thevenin's equivalent resistance by using step number 3. Now we move to step number 4. What is the step number 4? Step 4. We will move to step number 4. So what is the step 4? So drawing the equivalent circuit, Thevenin's equivalent circuit, and connect RL 10 ohms. So what is the Thevenin's equivalent circuit? So we have studied. So a series resistance is connected to the voltage source VTH, which we have calculated in step number 2, VTH, which is a 17.5 volts, which we have calculated VTH, and in series with your RTH Thevenin's equivalent resistance. This is the 5 ohms, which we have calculated in step 3, and this is the terminals A and B. This is the terminals A and B, and this will be called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now we have to connect a load resistance which we have removed in step number 1. What is the load resistance which we have removed? RL. RL is 10 ohms. We have connected the load resistance RL in this circuit, right? So this is the step number 4. Drawing the Thevenin's equivalent circuit. What is the Thevenin's equivalent circuit? VTH in series with RTH, and we have connected the load resistance RL. Now we move to step number 5. Last step. The step number 5 to apply Thevenin's theorem. Step number 5. Finding the current. Finding the load current IL. So how you will find out the load current? Just this is a simple circuit. if you write the equation IL is equals to, what is the IL equation? VTH by 2 resistors are connected in series, RTH plus RL. RTH plus RL. So what is the VTH? 17.5 volts. 17.5 volts divided with your RTH is 5 ohms and your RL is 10 ohms. RL is 10 ohms. So from that you can easily calculate your VTH by RTH. What is the value you can find out? So that is 17.5 by 15. 17.5 by 15. So that from that you can easily find out that is a value. It is a 1.16 amperes. So like this we can easily find out the IL value. The current flowing to the 10 ohm resistor is the 1.16. So by applying these 5 steps, we can easily find out the Thevenin's theorem solution to find out the current in this 10 ohm. So we can see here, find the current flowing to 10 ohm resistor. In step number 1, just we remove the load resistance from the circuit. And step 2, we found the Thevenin's equivalent voltage VTH here. We got that voltage is 17.5 volts VTH value. And third step is finding the RTH after replacing the all sources with their internal resistances. And we got that value is the 5 ohms. And last, the fourth step, drawing the Thevenin's equivalent circuit and connect the load resistance RL. So we have connected the 2 volt VTH in series with RTH, and we can call this the Thevenin's equivalent circuit. And after that, we connected the load resistance RL 10 ohms, and we have written an equation, very simple equation, because this is a simplified circuit rather than first step complicated circuit. We have simplified the circuit, and very easily you can write the equation IL is equals to VTH by RTH plus RL. Just substitute the values. VTH you found in second step, that is a step 2, 17.5 volts, and RTH value you found in step number 3, that is a 5 ohms, plus your RL value which is removed. You want to find out the current, that is a 10 ohms, and when you substitute, so finally you get the IL value, it is 1.16. So this is the example of one of Thevenin's theorem. Thank you.